Inequalities lesson 4. The most well-known and frequently used inequality is most likely arithmetic mean geometric mean inequality, or widely known as AM-GM inequality. The term AM-GM is the combination of two words, arithmetic and geometric mean. The arithmetic mean of two real numbers is defined as a plus b divided by 2, and the geometric mean is defined as the square root of ab. The simplest form of the AM-GM inequality is the arithmetic mean of two non-negative real numbers is always greater or equal than their geometric mean. Equality holds when a and b are equal. To prove this, we start with square root of a minus square root of b to the power of 2 greater or equal than 0. If we expand the left side of this inequality, we have a minus 2 square root of ab plus b greater or equal than 0, which is a plus b greater or equal than 2 square root of ab. That is the same as arithmetic geometric mean inequality. Equality holds when a and b are equal. If a and b are equal, square root of a minus square root of b to the power of 2 equals 0. Therefore, a plus b divided by 2 equals square root of ab. Let's have our first example using arithmetic geometric mean. For any three real numbers a, b, and c, a2 plus b2 plus c2 is always greater or equal than ab plus bc plus ca. We know for any two non-negative real numbers x and y, x plus y divided by 2 is greater or equal than square root of xy. a2 and b2 for any real numbers a and b is always greater or equal than 0. Therefore, a2 plus b2 divided by 2 is greater or equal than square root of a2 b2, which is the absolute value of ab. Notice that square root of x2 is always equal to absolute value of x. An absolute value of x is always greater or equal than x. When x is a non-negative number, absolute value of x is equal to x. And when x is negative, absolute value of x is greater than x. Therefore, a2 plus b2 divided by 2 is always greater or equal than ab. This means a2 plus b2 is greater or equal than 2ab. Similarly, we have b2 plus c2 is greater or equal than 2bc, and c2 plus a2 is greater or equal than 2ac. By adding these three inequalities, we have 2a2 plus 2b2 plus 2c2 greater or equal than 2ab plus 2bc plus 2ac. If we divide both sides of this inequality by 2, we have the desired inequality. For n non-negative real numbers a1, a2, an, their arithmetic mean, which is a1 plus a2 plus an over n, is always greater or equal than their geometric mean, nth root of a1, a2, an. Equality holds when a1, a2, and an are the same. To prove this inequality, we use the well-known Cauchy's proof by induction, the special kind of induction that we prove in next lesson. Thank you.